In this video, we'll see what conclusions we can make when we compare the gradients of different lines. Parallel lines are lines that are equidistant from each other and will never intersect. These lines have to have the same direction and steepness and therefore have the same gradient. Another term that fits with gradients is collinear points. Collinear points are points that lie on the same line. So if I was to draw a line segment between points A and B, and then also between points B and C, it will form one continuous straight line. To prove that it is one straight line, I need to show that the gradient from A to B is the same as the gradient from B to C. Although this requirement looks similar to that of parallel lines, for collinear points there will always be a common point, so a point that is part of both gradients. So you can choose to compare the gradients of AB and BC, or even that of AB and AC, as long as you have a common point. Because if you draw two lines from the same point with the same gradient, it will form the same line with all the points on that specific line. Let's look at some examples about this. Example 1. Given points A, B, D, and E, prove that AB is parallel to DE. We just saw that parallel lines have the same gradient. Therefore, we need to determine the gradient of line AB and then also the gradient of line DE to see whether they are equal or not. And for this, I'm going to substitute into our formula for gradient, and the y values are 5 and 1, and the x values 4 and minus 4. This gives us a fraction of 4 over 8, which can be simplified to a gradient of a half. For line DE, we have the coordinates 4 and minus 2 with 8 and minus 4. This gives us 6 over 12, which can also be simplified to a half. And now we can make the conclusion that the gradient of line AB is equal to the gradient of line DE, and therefore we can say that AB is parallel to DE. When answering analytical geometry questions, it is important that you write very systematically. So even though it was clear that the two gradients were equal, it is necessary to write so that you can see the gradients are equal, so that from there you can make the conclusion that the lines are then also parallel. Example 2. Determine whether the points D, E, and F are collinear or not. In analytical geometry, it helps if you get a rough sketch in mind, if no sketch is given. We already know that collinear points will have the same gradient between any two of these points. So we now have the choice of determining the gradient between D and F, that between F and E, and even the gradient between D and E, and compare them. If two of these gradients are the same, the points will be collinear. I'm going to choose to start with the gradient of DF by substituting the coordinates D and F. So I'm going to start with the y value of point D and subtract the y value of F, and then the x value of D minus the x value of F. This gives us a fraction of minus 3 over minus 6, and therefore the gradient is a half. Now I'm also going to determine the gradient of DE. For this, I'm going to start with the y value of D and subtract that of E, and then take the x value of D minus the x value of E. This will give us minus 6 over minus 12, which once again is a gradient of a half. So now we can make the conclusion that these two gradients are equal, and that means that the 3 points are collinear. Two lines that are perpendicular intersect at 90 degrees. These two lines will definitely not have the same gradient anymore. Firstly, their direction will be different because the one line will be decreasing, having a negative gradient, and the other line then increasing with a positive gradient. Next, let's have a look at the steepness of these two lines. Remember that the gradient represents the change in y value over the change in x value. And for our first line, the change in y value will be 2 units for every 1 horizontal x unit. So the gradient is 2 over 1. Moving to our green decreasing line, you will see that we move 2 units on the x-axis when we move down 1 unit for the y. So the gradient will be -1 for every 2 on the horizontal axis. So here you can see that other than the fact that one is positive and the other negative, the one gradient is also the reciprocal or swapped around version of the other. If we now go further and multiply these two gradients with each other, you will see that the gradient of 2 multiplied by -1/2 gives us a product of -1. For perpendicular lines, the product of the two gradients will always equal -1. Example 3. Given points A, B, C, and D, prove that AB is perpendicular to CD. We now know that for perpendicular lines, the product of the gradients should equal -1. So I'm going to start off calculating the gradient of AB, and for that I'll have -7 minus -3 over 6 minus 3. This gives a gradient of -4 over 3. And now I'm also going to determine the gradient of CD, starting with the difference between the two y values and dividing that by the distance between the two x values. This gives a gradient of 3/4. Next up, I'm going to determine the product of these two gradients. This will then be -4 over 3 multiplied by 3 over 4, which is a product of -1, and therefore we can say that AB is perpendicular to CD.